Okay, we're going to try this and see how well it works. I'm going to give you a little rundown of sections 1.7 and 1.8. The rest, anyway, pieces of what we need to know to get through the homework. We looked at linear inequalities in one variable the other day and ended up with statements like maybe x is less than or equal to 4, where we drew a picture of what that meant. Since 4 is included, we used a square bracket there. Numbers less than 4 go to the left, and then we used interval notation to explain that set of numbers. What we're going to look at today, in this video anyway, is I think mostly from section 1.8, and that has to do with absolute value inequalities. Sorry about the handwriting. Just like in our absolute value equations. Let's start with something simpler. Every time we're given an absolute value, we know that we're going to have two pieces to this thought. We said when the absolute value of x plus 3 was equal to 5, the stuff inside either represented positive 5 or negative 5. Maybe today instead we're going to call that less than or equal to. We're still going to have two statements. We're going to have one that revolves around the number 5, and we're going to have one that revolves around the number negative 5. And since this is no longer an equal sign, I need to figure out what to do with the symbols in between. In one of the statements, we're just going to keep the symbol just as it is in the given problem, and we're not going to change it at all. So x plus 3 is less than or equal to 5 is one possibility. For the other one, when we hop over here, we're going to flip the sign and flip the sign, meaning the less than turns into a greater than, and the positive 5 turns into negative 5. These are the two inequalities that we're going to set up to solve for x. One step on each of those, we get our x all by itself. Now 2 is over here, negative 8 is over here. We're going to graph both solution sets on the same number line. And so if we need to be less than or equal to 2, I'm including the number 2. Less than means go to the left. Now if I'm greater than or equal to negative 8, greater than goes to the right. Also because it's or equal to, we're going to put a square bracket there. Now the key to these is after you set both of them up, we're either going to find the union or the intersection of those two sets. So I have to figure out, am I thinking about both of these being true at the same time, using the word and, or is it either or? The key is when you have a less than or equal to sign, absolute value of stuff is less than a number. Less than is going to be your and. Now and has to do with intersection, and we did that way back in like R.1. And if we intersect two sets, that means I'm looking for the spot where both lines are at the same time, which means on this particular graph, we're looking at all of the numbers between negative 8 and positive 2. Okay. So our solution set for this inequality, it says if we choose any number between negative 8 and positive 2 and plug it in up here, its absolute value should be less than or equal to 5. So if I plug in 0, 0 plus 3 is 3. 3 in absolute value is 3, which is less than or equal to 5. If I pick something like negative 9 or positive 5, those aren't going to work. If we have the absolute value of some stuff, it is greater than or equal to a number, then in terms of setting up our two new inequalities, it works the same way as it did on the other problem. One of our inequalities says I'm going to take the stuff greater than 7, just pretend that the absolute value symbols weren't there at all in the problem initially. Then when I go to write my other piece, I keep my x minus 2, I flip the sign, and flip the sign. Greater than becomes less than. 7 becomes negative 7. Those are the two inequalities that we're going to solve for x. So I add 2 to both sides, I add 2 to both sides, and just as before, we're going to graph both solution sets on the same number line. So positive 9, negative 5. If I'm supposed to be greater than 9, those numbers go to the right from 9. Because it just says greater than and there's no equal to symbol, I'm going to put parentheses there to indicate that 9 is not part of my solution set. This statement here says x is less than negative 5, which less than goes to the left. Number's still not included, so I'm going to use parentheses there as well. Now the next thing we have to decide is, am I going to take the union of these sets or the intersection? And if I started with a greater than or equal to symbol in my original problem, or is the word I'm after there. Or indicates I'm creating the union of those two sets, and the union is anything that's touched. Think about, we just had finite sets in R.1, where you think about dumping them all in a pile and making a list of everything that's there. With intervals, not quite so easy. I can't make a list. So what I'm going to do is use interval notation to describe this set, that piece of the graph. Interval notation to describe this piece of the graph. And then I'm going to use the union symbol to indicate that anything in either set is part of my whole big solution set. If I pick negative 12 for x, it's down here, it should work. If I pick 10 for x, it's up here, it should work. If I pick anything in this open space, it will not work for x. But anything in either this bottom set or the top set is going to work. I'm going to try to get one more example in real quick and then call this video good. Let's say we have 2x plus 3 is less than 5. Remember, when you're setting up your two inequalities, you don't ever change the stuff in the absolute values. So, can't get my line straight today. So we leave the 2x plus 3. We say that stuff's less than 5. Leave the 2x plus 3. Flip the sign, flip the sign. When we solve for x, I think I'm about to get interrupted. We'll get x is greater than negative 4. Right, because this is a less than, oh, I lost my bearings here, then I know that they're going to be connected with the word and. Okay, less than is tied to the word and, which means after I graph my solution sets, I'm going to take their intersection. Whoa, sorry. So here's 1 and negative 4. And from 1, I'm going to the left. From negative 4, I'm going to the right. And the intersection of those two sets is the point where they overlap, points where they overlap, which is the set between negative 4 and positive 1.